Hello everyone. Let's look at few questions on linked list. Our first question we'll be looking at is add two numbers. So we have given two linked list 1 and 2, and now we need to add both the linked list in a separate new linked list. So we have L1, 2, 4 and 3 and L2, 5, 6 and 4. And the addition of 2 and 5 is 7, 4 and 6 is 10, so 0. And then 1 is carry over. Then 4 plus 3 plus carry 1 is 8. So we have 708. Let's look at how we can implement this. We will create new dummy element, dummy list, and initialize it with a 0. And then we will have a current element pointing to dummy. And then we will create a carry variable. Now we will iterate till we have a list 1, data in list 2, or a carry available. So while L1 or L2, or we have carry, we will have value, we will store uh, uh, list 1 value in value 1. So we'll have L1 dot value. If we have L1, if we don't, we will have 0. Because we are using the OR condition, right? Either list 1 or list 2 or carry. So if list 1 is null, in that case, we are assigning it with 0. And we have V2, which is L2 dot val. If L2, else we will assign it to 0. In total, we will calculate with V1 plus V2 plus whatever carry we have. So currently it is 0, but in the next iteration, if there will be some carry, it will be added. Now I will update our carry to total divided by 10. So here if you see 6 plus 4 is 10. So if we divide 10 with 10, we have 1. So 1 is carrying over, right? So here 10 divided by 10 is 1. So our carry is 1. And then in our current dot next, we will save, we'll create a new list node, and the value which we are getting from the addition, we will store in the list node. So which will be total mod 10. So here if you see 6 plus 4 is 10 and 10 mod 10 is 0. So we are storing 0 like that. So doing a mod 10, and then we are assigning current to current dot next. To that, we see if we have list L1, uh, list 1 we have available, then we will move our list 1 pointer to list 1 dot next. And similarly, if we have list 2, we will assign list 2 to, that means move to the next pointer. So this is how we will create our current, which will store all the values, and then we will return dummy. We are always storing dummy first value to 0, because in some of the questions it will cause confusion. So first value we always initialize to 0, and from second value we are storing it in the linked list. That is why we are returning dummy dot next. That is, ignore the 0 1, and then from the next one return it. So let's run this. You see now the machine is working. It is working now. Moving on to the next question, we have merged to sorted list. So we have list 1 and list 2, and they both are sorted 1, 2, 4, and 1, 3, 4. Now we need to merge it, and we need to merge it so that the resulting list is also sorted. So how we can do that is again the same. First, we will create the dummy, right? So let's see how we will approach this problem. So again, we will create a dummy, and then we will have our current dummy. So why we are doing this? We are assigning dummy to current so that our head node is not lost, and we will iterate the current while list one and list two. So until we have elements in both list one and list two, we will iterate. Then we will check if list one dot value is less than list two dot value. If so, in the current next variable, we will assign our list one node, and then list one we will assign it to list one dot next. What are we doing? We are first checking until we have elements in both list one and list two, and then we will check if list one value is smaller than list two value. So if so, what we will do, our current is pointing at node zero, and so its next node will have value list one value, which is one, and then list one we will move to next. List one dot next. So once we have assigned one into our dummy, we will move to two. Else, we will do the opposite. So current dot next will be list two, and list two equals to list two dot next, right? And once we do that, now our current dot next is now pointing to the our load one, right? Then we will move to the next. We'll move our current to next. So what we did, we have list node zero, and then list node zero. The next of list node zero, we assigned it to one, and then we move to the next node. So we did current equal to current for next. And after we do that, we will do a current dot next. So now this loop is running only till we have values in both list one and list two. Now let's say in list one, any one of the list is longer. So in that case, once one list is over, we will break out of this while loop. So if there are remaining elements, we will assign it to the current next. So what we will do, current next we will do list one. If list one is there, our current dot next will point to list one. Otherwise, it will point to list two, right? And if there is nothing, then it will point to none. So current dot next would be none. And then same thing, we will do a return dummy dot next. Let's run this. We say our result is a success. If you see the solution is accepted. This is how we can implement this. Now moving on to the next question, we have merge k sorted list. So now it's similar to the previous question, but instead of sorting two lists, we are sorting k list. So the list can be 3, 4, 5. It can be any. So let's see how we can approach this. One approach can be similar to the previous approach. So let's copy this and show you. Let me copy this and paste it here. Right? And we will name it a different function. Definition merge. And here we'll do self list 1, list 2, right? So now what we're doing is the same thing that we did in the previous question where we were merging two arrays. The same method we for the merging two arrays, merge two list. Okay. For merging two lists, we have created this method, right? Now let's see how we will implement this as here we will create a merged variable which will be pointing to null, and that what we'll do, we will look through each list. So we have lists, and inside this lists we have multiple lists, list 1, list 2, and list 3, right? So we'll go through each list. Inside the list lst in lists. So we will iterate over each list first, second, third, like that. And then what we will do, now this variable that we have created, this will be our resulting variable, and then we will call this self dot merge to list. And to merge to list, what we will do, we will send first merged list and the second one the list, right? And then we will return merged. So what we did is first time our merge is none, okay, and our loop ran for our first list 145, right? So we call this method merge to list, and it merged none with list 2, right? So what happened was this while loop did not executed because our list 1 was null. So in that case, what happened, our current just added list 1 145 into the current and then returned it back. Okay, now second time we have our merged. Okay, this is merged. Our merged has first list and our LST has second list. Okay, and now this method will merge list number 1 and list number 2 in a sorted way, right? And in the third iteration, our merged will have our list 1 and list 2 in one array, and it will be merging it with the third array. If you see now, we run this. The solution is accepted. Uh, right? This is accepted. It's a correct solution, but the problem is this is slow. So instead, we can use minimum heap. So what is minimum heap is heap it does is heap stores the data in a sorted manner. So our min heap, we push the head of each list into the minimum heap, and the minimum heap always gives us the smallest node, right? So let's see how we will implement this. We will create a heap array, right, which has nothing right now, and then we will create a dummy list node 0, and then our current will point to dummy. Now So now what we are doing is we are iterating over each list 1, list 2, and list 3, and we are storing the first node, right? For I comma node in enumerate lists, right? So if we have node, that is, if there is something empty, then it will not consider it like it's empty brackets. But if it's not empty, then so what we are doing, we are iterating over each list's first element, right? I comma node in enumerate. So first time I will be 0, okay, and node is the head. head of our first list. So our head is 1 and I is 0. So we will store 1 in the heap, and then in the second iteration our I will be 1. So our I will be this one and the head will be again 1. And in the third iteration our I will be 2 and our node will also be 2. So we have 1, 1 and 2 stored inside the heap, and the second element we are storing is I. So I as in for, let's say we have two ones. First one is from first list and second one is from second list. So I is to check which list our one belongs to. So our first one will be stored with 0, 0th position, and our second one would be stored with 1i, right? It is to uh, so that the order is not disturbed. Yep. So this is important for stable sorting, right? For in stable sort, our order is preserved, right? So we have our heap with first element of each array, and then we will, until and unless we have some element in the heap, we will loop through it, right? And then we will take back what we stored, val I and node from the heap. So now what will happen is we have stored 1, 1 and 2 inside the heap, and the heap returns the smallest element. So here if you see, now our smallest element is 1 here and 1 here. So there are two elements. So how will heap decide which one is smallest? So this one comes from 0th position and this one comes from 1th position because we are storing I. So it will return this one. Correct? That is why we are storing I here. And then we are storing node because node we will be pointing to the node. And now what we'll do in the current dot next would be pointing to our node. Right? This is value, this is node. And then we will move our current to current dot next. Right? So we have stored our one inside our current next because our current was 0 and its next became 1. And then we moved current to the next element, right? Now, since we took out 1 from this heap, the this 0th space got empty. So what we will do, we check if node has next. That is, once we took out this one, that place has become empty. So we will checking if one has a next element, which is 4. If it is present, then at the same location, at the 0th location, we will push it. Push the node 4. EQ dot the same I which we are having, which we got from here, and okay. And the next element we are storing, and the next element value node dot next dot where I and node dot next. Okay, and then we will return. Let's see. Yeah. So now this is also working. The solution is accepted. Let's submit it. Okay. This solution is accepted. Let's move on to the next question. We have remove nth node from the end of the list. So we are given a list 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We need to remove the nth element node from the end. So our n is 2. So our second node from the last, first node is 5. Second node is 4. So when you remove this 4, now our resulting linked list would be 1, 2, 3, and 5. That is 4 is removed. Okay, how can we do this? We have n equal to 2. So one way to do is using a slow and fast pointer, right? So our n is 2. So what we will do, we will move our fast pointer 2 times, n times. So our fast will reach to the third node and our slow will remain at 1. Okay, and then we will move one by one. So the fast will move to 4, slow will move to 2, and then our fast will move to 5, slow will move to 3. And now our fast cannot move because there are no next element, right? And at that point, our slow has reached the correct point where we need to skip 4. So then what can we do? The 3 which is pointing to next 4, we will skip it and 3 will point to the next of next. So the 3 will be pointing to 5. So let's see this in action. We have dummy next node. So we are adding again 0 in the dummy and then we are giving it to the head. So our dummy will have 0, 1, 2, 3, 4, 5. 0 is just dummy. Okay. We first our slow and fast both will be pointing to dummy. And then we will move our fast. So what we'll do for underscore in range. If we don't want to do anything with the I, we can give underscore because we don't need it. N plus 1 times. So our n is 2, n plus 1 is 3. Why we are doing n plus 1? Because we have added 0 to the dummy, right? So our one element has increased. That is why we have added 1 to the n. And now we will just move our fast pointer. Fast would be fast dot next. Right? So now our fast has reached uh, n plus 1 steps, which is here, right? So now we will move both slow and fast one by one until our fast reaches the end. So what we will do, while fast, now we will move both one by one. So slow equal to slow dot next and same for fast. Okay, now till we have fast, we will move both one by one. Now fast has reached the 5. So this is where the while loop will break. And now once the while loop breaks, our slow pointer has reached the exact point where we need to skip 4, right? So what we will do, our slow dot next would point to slow dot next, right? And then we will just return our dummy dot next. Our first element we will ignore and we will just return the next element. Let's run this. If we see it is accepted. 1, 2, 3, and 5 was the expected, and this is what we got. This is accepted. So let's move on to the next question. We have intersection of two linked lists. So we are given two linked lists, and at one point they are having same elements. So if you see here, list A contains 4, 1, 8, 4, 5. List B contains 5, 6, 1, 8, 4, 5. That is 8, 4, and 5 are common in both list 1 as well as list 2, right? So we need to return that point at where the intersection has started. So intersection has happened at 8. At 8, both are intersecting. So how we can approach is, let's look at this visually. How we will do that is, let's say if we move from here. So how many nodes we need to cover? 1, 2, 3, 4, 5, right? So we are covering 5 nodes if we go from here. And if we go from bottom, we are covering 1, 2, 3, 4, 5, 6. We are covering 6 nodes. Okay. Now let's say our pointer has covered the upper nodes. Okay. And let's make it cover the bottom nodes as well. So see, if we add 5 plus 6, okay. let's say our pointer first moved from 4, 1, 8, 5, 4, 5. It covered 5 nodes. And let's move the same pointer to 5. And then let's see how many pointer nodes it's covering. 1, 2, 3, 4, 5, 6. So we add 6. So total nodes covered is 11. Okay. Now let's see. Look at the second pointer. Our second pointer has covered 6 nodes. 1, 2, 3, 4, 5, 6. First. And let's make it cover the first node. This is 1, 2, 3, 4, 5. So 6 plus 5 equal to 11. So if you see, if we take two pointer and make both the pointer traverse the same list, right? It will cover the same distance, right? Okay. Now let's see our pointer one P1 is at 4, P2 is at 5. Our P1 goes at 1, P2 goes at 6, P1 goes at 8, P2 goes at 1, P1 goes at 4, P2 goes at 8, P1 goes at 5, P2 goes at 4. So P2 has not reached the end, but P1 has reached the end, right? So our P1 will now point to 5. Okay. So our P1 goes to 5, P2 goes to 4, to 5 again, this end one. Okay. Now P1 goes to 6 and P2 goes to 4. Then our P1 goes to 1 and P2 goes to 1 again. And then our P1 and P2 both will reach this node 8, right? So if we traverse it like this, at one point they will meet, correct? So this is how we will be approaching. We will we will have two pointers, and once they reach the end, we will assign it to the second node. So let's look at the solution. First, we will check. So if any of the list head A or head B is missing, in that case, there will be no intersection, right? Now what we will do is we will create C1, which is pointing to head A. Let's create C2, anything, head B, right? And we will iterate till both are equal. C1 is not equals to C2. Till then we will be iterating. Now what we will do, C1 we will make it as C1 dot next. Okay, till how long will we do it? Until there is C1 available. Okay, if C1 is exhausted, right, our C1 will point to head B. And same we will do for C2. C2 will move to C2 dot next until we have C2. And once our C2 is exhausted, it will point to head 8. Right? And once they both reaches 8, then we can return either C1 or C2. So we will return C1. So let's run this. If the solution is accepted, our intersected at 8 and our expected is intersected at 8. Submit it. And this is accepted. Let's move on to the next question, which is reverse a linked list. So here we are given a head, given the head of a single linked list, reverse the linked list. So how we will reverse it? If we see 1 is pointing to 2, 2 is pointing to 3, 3 is pointing to 4, and 4 is pointing to 5. Now we want to reverse it. So 5 will point to 4, 4 will point to 3, 3 points to 2, and 2 points to 1. So our resulting array, our linked list becomes 5, 4, 3, 2, 1. The head we provided is 1, 2, 3, 4, 5, and our output should be 5, 4, 3, 1, 2. Right? So what we will do is, let's look at the implementation. It's very simple. I mean, we just need to reverse the direction of the next element. So how we will reverse it is, we will create a previous variable which is currently pointing to none. Because if you see here, 5 is not pointing to anything else, right? So now point 5 needs to point to 4. And if you see 1 is pointing to 2, but if we reverse this, 1 is not pointing to anything. So we have created a variable previous equal to none. And then our current, we will we are taking the head to the current, right? So that we don't lose track of the head. And then while we have current, I mean, until unless we have a linked list, we will keep going through it. What we will do? So we have one, we have two, correct? So we don't want to lose track of our pointer. So we will store. So we have one, we have two, right? One is pointing to two. Now we don't want to lose track of two. So the current dot next, which is two, we are saving it in a temporary variable next. Then what we will do? Our current dot next would point to previous, right? Our one is pointing to two, right? So we took the two inside the next, and then our one dot next we made it to previous. So previous is none. So now one is pointing to none. And then what we did, previous will make it as current. That is, our one is pointing to none, and because our previous was none, and now we have made previous as one, because once we move to two, the previous of two is one, right? And then our current we have moved it to next. So our previous, so our one became the previous element, and then our current element is become two. And now let's return. And since our while iterating, our previous will reach 5, we will return previous. Let me show. Okay, our correct variable name is next. So if you see now, solution is accepted. Let's submit it. This is accepted. That's it for today. Thank you. See you tomorrow.